good afternoon, good evening, good morning, depending on what it is for you guys today. Math 30 Foundations. We're going to get into day 9, and this will be some more sinusoidal graphs. So this will be graphs of sinusoidal functions. So we'll be trying to find equations of midlines, periods, and amplitudes. So we're going to be looking at that today. It's pretty short. It might be handy to have some graph paper around, as I'm going to, some of these I have to show. The book has graphs to analyze them, but I have to bring up some graphs to use them on myself as well. So I'm going to just draw a few here. Okay, so what are we going to do today? What's our plan for today? Pretty straightforward here. As soon as we get this set up, there we go. Okay, so this is day 9. We're going to be looking at Unit 4, Foundations, and we're looking at the equations for midline, amplitude, and period. Okay, and we're going to be looking at some examples. Graphs. Okay, so the first thing is, let's start off with the period. Okay, and this is the horizontal, we did this yesterday, distance between 2 consecutive maxes or 2 consecutive mins. Okay, that's another way to look at it. It takes as long as it takes for the graph to repeat itself. On a sinusoidal curve, so on anything that follows a sinusoidal type path. Okay, so an amplitude, okay, so the equation for the amplitude the equation for the amplitude of the function is simply the maximum value minus the minimum value divided by 2. Okay, I'll do this with a marker here. Or not equation of the amplitude. We'll just say amplitude. We'll use capital A for short. So this is going to be max value, subtract the min value, divided by 2. Okay. The equation for the midline is almost very similar, but it's different sign in between. Okay, the equation for the midline of the function is, so when we're talking about sinusoidal functions, we're talking about functions that repeat and follow that sine wave up and down type pattern. Okay, and that's what, but they're not exactly maybe perfect sine waves or something, but they're close. Okay, the equation of the midline is easy. It's y equals the max plus the min divided by 2. Okay, and it's y equals. So that'll give you the equation because that'll be that y. It'll give you the horizontal line. Okay, so let's look at an example graph or two with these, analyzing these two things. Okay, so I'm going to use some graph paper here. So let me pull out some graph paper. Okay, so let's put some graph paper down. Okay, now you can get all kinds of sinusoidal functions. You can have a negative positive graph. You can have a positive graph just with positive numbers only, like in the first quadrant. It depends. So let's do a T-bar graph here. So let's set up first of all. Give me a second to draw it first before you sketch it. Okay, so to make sure that we're on the same page. Okay, so let's go in the middle here. Let's give ourselves some place to write as well. So let's go about like that. Okay, and we'll label up our graph. Let's say that as we're going on the y here, okay, this will be 0, this will be 10, 20, 30 going up, 10, 20, negative, 10, negative 20, negative 30 going down. And let's go 2, 4, 6, 8, 10, 12, up to 14 here. And this is seconds. And this is meters. Okay, now let's do a sinusoidal graph. So I want you to start down here at negative 20. Put a dot. Okay, we're going to do a sinusoidal function here. And let's see, let's go down. Let's put another one at 6. Put another one at 12. Okay, those will be our minimums. Okay, and then let's put our maximums halfway in between at 3. Let's go at 10. And go at, okay, go from 6. We have to do another maximum in between 6 and 12, so that'll be at 9. So put another maximum at 10 at 9. Okay, and that'll be a shape of our curve. And if you want to come and draw that sinusoidal shape like this, it's raining pretty good here. Okay, so there's our sinusoidal curve. And the question is, find a max and the min. Okay, B, the equation of the midline. Okay, C, the amplitude. D, the period. Okay, and let's see if they get, I think that's pretty much all they kind of ask in our examples there. The domain and range, they might ask you. Okay, the domain meaning the values of y and the range. So let's do that because we haven't done that yet. Okay. Ooh, she's raining good now. Guess I didn't have to water the garden. All right, so here we are. Okay, let's say that this goes on and on and on and on forever. So like that. So we'll put arrows at both ends so that we know that it's going to keep on going and circling around and around and around and around. Okay, so it looks like that. Okay, so the max and the min values. So the first thing we're going to do is we're just going to change our color here. And we're going to say, okay, well, there's a min value, there's a min value, there's a min value, min. There's a max value, there's our max value. So we could say that the max is at 10 meters and that the min is equal to negative 20 meters. Okay, the equation of the midline. So the equation of the midline is y equals max plus min divided by 2. Y equals the max plus the min divided by 2. Okay, we could also eyeball it if we wanted, but this would work. So our max value of 10 meters plus negative 20 meters divided by 2 equals y equals negative 10 meters over 2, which equals negative 5. So that means y equals negative 5 is our midline. Okay, so that means right here is the equation of the midline if I draw it in there. Okay, half of it's there, half of it's there. Kind of, you can see it there. The midline. Okay, that was easy. Okay, what about the amplitude? Okay, the amplitude is a similar one. So we'll do it here. But that's max minus the min divided by 2. So amplitude, I should put the A there, sorry guys. The max minus the min divided by 2. So the max would be, well, 10 minus 20 over, or sorry, minus negative 20. It's kind of tricky, right? Okay. Okay, so it's 10. I'm going to write that better so that we don't get confused. 10 minus a negative 20. Okay, so this is going to be 30, which equals 15 meters. So our amplitude is 15 meters, which makes sense. If you go from the midline, 5, 10, 15. If you go from midline, 5, 10, 15. Makes a lot of sense. D, the period. Okay, the period is from a max to a max. So this is a period. Or you could have done it from a min to a min. So this is going to be from 3 to 9. So the period goes 9 seconds minus 3 seconds equals 6 seconds. So the period is going to be 6 seconds long before it gets to the next max. So this should be 6 here. 1, 2, 3, 4, 5, 6. Perfect. So we got a period of 6 seconds. And the last one, the domain and range. Okay, the range is the values of y. And the range is the values of y, and the domain is the value of x. So as you can see, the domain is, because we got arrows on both ends, it's from negative infinity to positive infinity. So we'll move this down a little bit here so we can do this. So the domain, all values of x. Okay, and that would be if we write that in set notation. Okay, if we're going to write it in set notation, it's from negative infinity to positive infinity. Uh, that's our interval there. And our range, it's everything greater than negative 20 and less than 10. So y is greater than or equal to negative 20 and less than or equal to 10. And this is our range. So all the values of y. Okay, so there's our domain, range, everything like that. And that is basically what they have for examples there. They analyzing a graph and looking for particular, those types of things. Let's see if they've got anything else here. Period, equation to midline, that is pretty much it. Okay. We'll do one more example because we have time, and then we'll give you the practice, okay? So let's do one more. Okay. Let's say, let's do the opposite of this one. Let's go, well, actually, I don't know if we want to do a sketch one. Let's try one more here. Let's get the graph paper out here. Sorry. Okay, so let's just do a positive graph only this time, okay? Rather than a T graph like we had last time. So let's say we go and we just take this corner like this. Okay, there's no negative values in this one. So let's go ahead and tick this up here. Let's say that this particular graph, let's call this one y, this one x, okay, and this will be in degrees. So let's say that this is 10, 20, 30, let's go 40, 50, 60, 70, 80, let's go all the way up to 100 degrees. 90 and 100 degrees. Okay, and let's say that this is the amplitude. So let's just say it's like ones. So let's say 1, 2, 3, 4, and 5. Hopefully the power doesn't flick when I'm doing this, because then I have to start over. Okay, and let's draw our graph. So let's start our graph. Okay, I'm going to use black here to put the graph down, or no. Yeah, not purple. What the heck? Okay, so let's start our first dot, a minimum dot. Let's do it here, right at 0 degrees and at 1.5. Okay, let's go 30 degrees and put a max. Okay, and then do 30 more degrees, so 60. Put a min again at 1.5. And do 30 more degrees, which would be 90, and put a max. And then just draw the sine shape in here. I decided to do an extra video here. I was going to go home and garden a little bit, but you can hear the rain. Okay. It's supposed to be symmetrical, but it doesn't look perfectly symmetrical. Okay. And then let's put arrows on both ends here so it's going. Oops, this one wouldn't go up. It would come down. Sorry, guys. Let me fix that. Oh, man, is it good. Pouring her down pretty good. Okay, so let's put that back up there. All right, so there we have our graph. So finding the same 5 questions again. So let's do the max and min values. So the max is equal to 3. A min value is equal to a 1.5, 1.5. Okay. The period here, we could go from max to max or min to min. Let's do min to min this time. So our period, okay, we've got to go all the way from 60 degrees all the way back to 0, and then to get there. And or if we did max to max, it would be 90 back to 30. So 60 degrees minus 0 degrees equals 60 degrees. So we have a period of 60 degrees in there. Okay, what about our equation of the midline? Okay, so the equation of the midline is y equals max value. Sorry, guys. Max value plus min value divided by 2. Okay, so we're going to have to stick with the decimals here. Okay, so max value was 3 plus 1.5 over 2, and this is equal to y. So y equals 4.5 divided by 2. Y equals, okay, that's going to be half of that, so it's going to be 2.25, something like that. 4.5 divided by 2, 2.25. So if we were to draw the midline, 2.25 would be somewhere in here. Okay, and that's equation midline. And if we did amplitude, that's max minus the min divided by 2. So 4.5 plus, or sorry, not plus, minus 4.5. Why am I got 4.5? I don't know. I was looking at the wrong thing. Sorry, guys. The max was only 3, right? 3 minus 1.5 divided by 2. So this is equal to 1.5 divided by 2. So the amplitude then equals 0.75. Okay, so 0.75 from there to there. 0.75 from there to there. Okay, and the domain, okay, all values of x. Okay, but the range, okay, it goes from 1.5, it's less than or equal to y, all the way up to 3. And there we have our second example. Okay, so let's take a look at, I didn't look at my preview here. Let me see where we are here. Okay, so we're sitting there, whoops. That's a good, well, it's not that long, 25 minutes. So I'm going to, fairly short topic. I'm going to give you a couple practices from page 536 and so forth. Okay, so let me just bring this up here. Okay, some of them are graph drawings. Some of them are more asking you about looking at the graph kind of questions. Okay, but they're very similar, dealing with all those types of things. So this is on page 536. To 537. Okay, so you can try number 1. Okay, there's 4 graphs there. Number 2. Three. Okay, those ones are all dealing with period, amplitude, midline. Okay, 4. Okay. Well, let's try. Let's try 9. That's a little bit of a word one there. And that should be good. You guys can do those 5 there. You should be okay. And then we'll get into some transformations as well. Now, your book doesn't cover that part of sinusoidal graphs, but I'll do it here with you next day. And then we're pretty close to the end of the year here. We should be close to finishing this unit up in the beginning of June here. I got some track meets coming up and stuff, so we'll see how that goes. And good luck. We'll stop her there. See you tomorrow.